class today. My name is Victor Digomo here. We are rounding up our class in the application of the laws of logarithm. It's not going to be the last anywhere. We will still be bringing up problems, but the process we are taking in teaching a particular topic is what I'm trying to explain, that we are almost rounding up this. Then subsequently, we can still be bringing up more problems in line with this topic, and then we can still be solving them alongside. All right. So remember, what we are handling is mostly critical problems that has to do with a particular topic which we have discussed. Like this one, I got it from WIC exam questions. All right. So if you look at this problem, it has to do with substitution. It has to do with substitution. Okay. So this question, what does it require from us? It says if log 2 is equals to x, log 3 is equals to y, and log 7 is equals to z, find in terms of x, y, and z log 28/3. Okay, there are some other problems I have seen in similar to this. Like they can give, if log 2, you may have come across such. If log 2 is equals to 0 point something, log 3 is 0 point something, log 7 maybe 0.7, something, and then they will ask you simplify this. That's to say, when you are able to reduce it to this log 2, log 3, and log this, you can now substitute those values into what you have simplified and find the result. The same thing is applicable to this one. So if you learn this, you can still do that one. I'm trusting God for that. All right. Let's see what happens here. My concern now is, how do I break this thing down to assume these values? So I have log 28/3. And you remember that in logarithm, that when we are subtracting the logarithm of two numbers, we take the quotient. So since the quotient is already here, I will return this to log 28 minus log 3. I'm sure that's okay. The next is, how can I break down 28 into factors that can give me things like this? So I have 28. Think 2 can go here and give me 14. 2 can go again and give me 7. Then 7 can go and give me 1. So do you see that within here, I think I have log 4 times 7. You see how I put it? Then minus log 3. And by product, this will become log 4 plus log 7 minus log 3. And with this now, I can rewrite it as log 2 raised to power 2. Then plus log 7 minus log 3. And you know what this is? It becomes 2 log 2 plus log 7, then minus log 3. Okay. With this now, we can make our substitution. So assuming what I was saying previously, that this log 2 has been made available as a decimal value, you substitute it here and multiply by 2. Assuming this one too has been made available as a decimal value, I'm thinking you must have seen those problems maybe somewhere. So please, this is the same way you handle it. Okay, so this will be 2x, because log 2 was given to be x. So this will be 2x plus log 7 was given to be z plus z. The minus log 3 was given to be y. So this is the extent we can go in that simplification, because we cannot be able to add or subtract anything there. Okay, so it's so simple. I think so. So if I don't think there's any problem with it. Okay, so I don't think so. One can be able to understand this and apply it any other place. I think so. All right. We are still going to be bringing more problems, as I said. Okay. But in the next class, I am going to, because I'm almost rounding up this class on logarithm, I'm going to introduce circle properties. We are going to be looking at sector of a circle, arc of a circle, chord and its properties, and theorems associated with chord, and yes, and then perimeter of a sector, and then from there we are going to launch into the circle theorems. Please, you don't have to miss those classes. That is the next level we are going to go into. Please, in this class, I have had a lot of classes on it already. It's on the playlist. Check out on those classes. Once you subscribe, you'll be able to access all the classes at once. Okay, please subscribe and then share to your friends out there, and then like our video. And then as you do that, you are promoting us, to be able to make more impact. Thank you so much for being there.